pronomoblast is being formed. It has an average size of almost 17 micrometer. It has an average size of what? Almost what? 17 micrometer. Now, let me tell you the mystery of red blood cell formation. The more mature the blast cell becomes, the smaller it becomes. Have you heard that before? Have you heard that before? Store it in your hard drive. Store it in your hard drive. The more mature a blood cell becomes, particularly a red cell, the smaller it what? Becomes. So because it is at the first stage, it doesn't mean it should be small and be growing big. Rather, it is the opposite. And so a pronomoblast has an average molecular weight of between 15 and what? 17 micrometer. It takes about 5 to 6 days to get to the level of erythrocytes. It takes about 5 to 6 days. But as the day passes by, it what? Reduces in size. It's very opposite of human beings. Right? As you are growing from childhood, you are increasing. But for red blood cell, it's the opposite. As the red cell is maturing, it is what? Reducing. That's the difference between we and your red cells. So that's your pronomoblast. And if you look at this pronomoblast, you will notice that the nucleus occupied almost the whole cell. Have you noticed that? If this is what is sent to the peripheral blood, you and I will not be breathing. Okay? So this nucleus has to what? Go. It has to disappear. If you don't know that before, know it now. And so when it starts developing into basophilic pneumoblast, it reduces from 17 microns to what? 13 to 15, so it should be smaller, right? Is the gap too much? It's still much. It should be a bit smaller. And the nucleus should what? Reduce. We should see what we call reduction, right? You get the difference now. While your red cell pronomoblast is developing, the size is what? Reducing, and the nucleus is what? Disappearing. Please don't be breathing as a med lab scientist without knowing how it happens. This is how it happens. You're a med lab scientist, so you should know this. So this is what? 13 to what? 15 micrometers. All together. So if you notice, the nucleus is already giving way, right? It has to give way. Now, it gets to the next stage, which is what? Polychromatic pneumoblast. Now, hear this. While this is 13 to 15, polychromatic pneumoblast should be what? 11 to 13. I pray I get the dimension correct. So maybe something like this. It's smaller, right? It's a bit smaller. That's just the idea. Just get to know that it's supposed to be getting what? Smaller. So, while the nucleus is condensing, condensation of nucleus, that's removal of the nucleus, right? Another one is what? Condensation of what? Nucleus. And then at the polychromatic stage, something else happens. Formation of hemoglobin begins. Have you heard of hemoglobin? Yes. Have you heard of hemoglobin? Yes. This is where the journey starts. Okay? Hemoglobin begins to what? form. You can call it what? Hemoglobinization. Formation of hemoglobin begins.